Okay, we'll get started. So welcome everyone. Before we start, I would like to remind you that we have a sign language interpreter and he should appear as a panelist on your screen. We also have live captioning for the event. So if you are on Zoom, you can click on the CC live caption icon, which should be at the bottom of your Zoom window. If you are experiencing any issues accessing the captions or the interpreter, please message us. And I would also like to acknowledge the work of Black in Neuro primarily takes place on Turtle Island, also known as North America, which is home to a diversity of indigenous peoples. We are all joining this event from places around the world, and so I invite you to take a moment to reflect on the lands you are joining from, as well as your relationship to those lands and the indigenous peoples who have and continue to inhabit them. Great, so good morning, good afternoon, or good evening, depending on where you are in the world today. It is so lovely to have you all here today with us. My name is Cleona Kelly, and I am a co-founder of Black in Neuro, and I'm also a PhD candidate in neuroscience at Aston University. So today is our third day of Black in Neuro Week, and so far we have had some fantastic events and speakers. If you have missed any, please do not worry, you can watch them back on our YouTube channel, Black in Neuro. And if you are tweeting about the events, please don't forget to use the hashtag Black in Neuro Week 2021 or BINW21. After this discussion, we still have one more event, which is the EEG Q&A between neuroscientists and Black hairdressers. And I can tell you this now, you do not want to miss that, okay? It is full of wisdom, gems, and just all-round Black excellence. And that will be streamed at 5 p.m. Eastern time. So make sure you all have your reminders set. Straight after that, we will be holding a Twitter Spaces session where you can come and debrief and discuss the day's events with us. So we'll look forward to seeing you there. All right, so today's panel will focus on inclusive neurotechnology. And in the past, we have talked about the difficulties in using EEG with curly or coarse hair. And this time last year, we had actually done a thread on it for our Neuroracism Day. And so this year we wanted to expand on it further because EEG is not the only neuroimaging technique we use, but is one where we are making steps in the right direction so far. So we will be discussing approaches to developing more socially just and inclusive neurotechnologies. And this will include EEG, of course, but also fNRIS and other light-based medical technology. So as you can see, we have our superstar panel on the screens today. These are experts from within the field of neurotechnology who will be sharing their knowledge with us. And so I will hand over to them to introduce themselves and their research to you. And we will start off with Arnelle Etienne. So if you'd like to share your screen, thank you.
Hi, everyone. Let me share my screen. Okay. So, hi, everyone. My name is Arnelle Etienne. I graduated from Carnegie Mellon in 2019. While I was at Carnegie Mellon, I started an undergraduate project about making EEG more inclusive to people with my hair type, because as you can see, I have the fro. So that's what this little intro is going to be about. I've done this work with the Neuro Web Lab, with Polka Grover, Sean Kelly, Dr. Christina Patterson at UPMC, and a whole bunch of other rock stars. So I wanted to shout out the people that have worked with me. I also want to shout out my family. This is some of my family, not everybody, but I couldn't be where I am without my family. So I wanted to shout them out. Okay, a little bit about me. So the first picture is from high school. That was my graduation in 2013. I was a very bright-eyed, like I can do anything type of girl. I was going to Carnegie Mellon. I thought I was everything because I went to public school and I made it to an institution like that. And I had no idea what was coming. I had no idea what was coming. So it was definitely a very difficult process. I think academia sometimes can, leave people in the cracks who don't know that they have mental illnesses. So I got diagnosed with ADHD midway through college, and everything made sense about my experience suddenly. And I wanted to shout that out because learning about that diagnosis kind of brought me to neuroscience. So, and really helped connect it in a personal way. So while I was at college, I had a great time. I was also not really doing well in a lot of my classes. And I point that out because I know that there are people probably watching who, struggle in classes and feel like they're not making it. And I felt like that 98% of the time. And I'm speaking on a panel for Black and Neuro. So I just want to, encourage people that you might be at your lowest moment, but just keep going because you're going to make it. So the picture on the right is me graduating. That's my little sister next to me, who is a software engineer, because we do it big in the Etienne family. You're a nurse, you're an engineer, you're doing something. But yeah, so I'm just that life really changes, but that's my little background. So to get into my research, EEG was developed about 100 years ago. But while it was being developed, people like me and other people were not really considered. They were kind of considering for the norm, which was the white person with straight hair. And the thing about this technology is that it relies on scalp contact. So EEG is basically just putting pieces of metal onto your scalp to get the electrical signals from your brain that basically creates a picture of what's going on in your brain that clinicians and technicians will interpret to get more information about the brain. So I focused on gold cup electrodes because there's several types of electrodes. There's caps, and caps don't really work at all for my hair type. It's like if you try to put a winter hat on, a fro, it's not really going to get too close to your scalp like someone with straight hair, or if you have braids. So I was looking originally with different types of electrodes, but the point is basically that on the left side, you have hair out just like how you might have it when you walk into a lab. And then I was like, what if you cornrow the hair? Because then you have exposed scalp contact that you can then sit the electrodes on, instead of the image on the right, the very right, of the gold cup electrode, where it's pushing against hair that's pushing back up against it and obstructing the contact between the scalp. So, when we were starting this work, when I started this work in 2016, that's what we were looking at. How do you, manipulate the hair with culturally competent styles that can easily be done by people in the community and also people in a lab space? And then we expanded that to, okay, and this is more pictures about gold cup. So on the left is someone with straight hair. There's a little bit of a space in between the scalp, but that's conductive paste, which actually helps to increase the conductivity and increase the signal. So that's me on the right. I placed a gold cup on my head and tried to take the picture as quickly as I could. And before I could pick up my phone, it was already pushing up against the scalp. So there's conductive paste underneath there, but there's also two curls underneath there that are pushing up against the gold cup. So we expanded this work and created a device that attaches to electrodes and can be retrofitted to electrodes to interface with the braids and thus create a stronger signal. And that is done by cornrowing the scalp into what's known as the 10-20 system, which is the internationally accepted way of placing electrodes. So these little dots right here is where you would want to place electrodes. And you would cornrow the hair along those columns to expose that so that you can put the electrode in there and have it stay. So Like I said, the cornrows create that reliable contact. It's secured, it's not moving, it's not going anywhere. And on the right is an earlier model, but it's the same principle, wings that go underneath the cornrows, and then the electrode attaches to it however you use it. So on this one works with the biosemi system. And the previous one works with silver chloride tabs, which we've used it with an Intan system in our lab. So the results of our findings were that when you have the hair like unbraided, like if I were to walk into a lab, that the impedance would be significantly higher than if you braid it, or if you further use the Sevo electrode, which is what we call our electrode, to adhere it to the scalp. And this difference, it's like an order of magnitude, and that's like pretty important when it comes to finding, to obtaining good contact on the scalp and then getting better signal. So I think during the panel, we'll talk a little bit more about why that's important. I just kind of want to give a quick overview, and also shout out to the team. This is, again, some of the people that we work with, because I can't fit everybody on the screen, but thank you so much to the team for the amazing work that they've done. It's a very interdisciplinary team, and I love that about us. Neuroscientists, clinicians, like undergraduate students, and I think that's really important too, which we can talk about later. And if you want to contact us about that, screenshot that. 3, 2, all right. So that's me. Thank you. I'm going to pass it over to whoever's next.
Great. That will be Dr. Jasmine Kwasa next, please.
Okay, I wasn't sure. I was like, who is it? So let me also share my screen, and importantly, share my sound, because I'm an auditory neuroscientist. Share. And where's it? Okay, I might go a little bit over, but I think it's worth it to tell my whole story and tell it thoroughly. So hi, I'm Jasmine Kwasa, Dr. Jasmine Kwasa, newly minted as of May. I'm an NIH DSPAN F99K00 fellow, and I can talk about what that is later, or if you want to contact me offline. I'm at Carnegie Mellon University in the Neuroscience Institute, and I'm currently on the land of the Osage Nation, the indigenous tribes and owners of the land. Okay. So I'm going to talk for a little while about my background, and it kind of leads into where I am today. So indulge me. I like to get to know people by name and by story. And so I encourage everyone to not only just meet people in their lives, especially in the Black and Neuro community, but get to know their stories, because it'll help you figure out yourself. And it's just always important to do. So I grew up on the South Side of Chicago in a huge African-American family, originally from Mississippi. And they poured all their resources and love into me so that I was able to go to the top schools in the Chicago public school system in Chicago. And I actually ended up at the Illinois Math and Science Academy, which was a boarding school, where I had all these great opportunities to pursue research, music, dance. I was a tutor, I was on leadership. But I also noticed a lot of racial and socioeconomic disparities that were in place, even though at a boarding school, you're supposed to have this like equality, and it was a public boarding school. So I figured it should be something that everyone should be able to access the same resources. But I found that wasn't true, and that kind of inspired me to get involved in the community. I went to school at WashU in St. Louis. I studied biomedical engineering, and I did research all 4 years on regenerative medicine, and then later on in brain-machine interfaces using EEG. So that was my first time working with it. Throughout that time, I still was involved in dance. I was in a K-pop dance crew. I was in the orchestra. I played violin. I did all this stuff, but importantly, I was really interested in doing educational outreach programs to Black St. Louisans, because I was actually born in St. Louis, but also because of the reasons that I saw at IMSA, which were, I wanted to make sure that I was giving back. I wanted to make sure that those pipelines to get other Black students or socioeconomically disadvantaged students into the STEM pipeline. And so that was one of my big passions. And I spent a lot of time doing that work, probably more than the lab work, to be honest. Okay, on to Boston. I went to Boston University, where I switched to hearing science using EEG as well. And we're using EEG and the tools from electrical engineering, so signal processing and modeling, to do cognitive science work. And so, again, I stayed involved in dance. I ended up certifying in a dance type of fitness program. And I really put my foot into outreach. And so I started working with the E3 mentoring program in Boston, and we had hundreds of girls coming through our program. I started the BU Underrepresented Graduate Student Organization. I felt super isolated there, so I figured let's try to get more Black people, get more Latinx people, Indigenous folks into these spaces. And it was really important that I worked in these groups because it was part of my identity as a scientist and engineer. And so even though all of these things helped me win fellowships and all these great accolades for my efforts, they were really a foreshadowing of the DEI work that I had to come later. And so finally, now I'm in Pittsburgh. Actually, I finished my PhD at Carnegie Mellon. My lab moved. And now I'm postdoc here. I identify as a cognitive neuroscientist and engineer, but I'm also a dance fitness instructor and educator. And I really do identify as an ethicist. And I'll get into that a little bit later. All right, I'm already over time. So I'm going to talk about a little bit about my PhD work and let you all know that I'm truly a cognitive neuroscientist first and foremost. So my work is on auditory spatial selective attention, and it's our ability to parse out and maintain attention on a single sound source when you're in a crowded environment. So you're in for instance, you're in a crowded cocktail party, there's a lot of music going on, there's people screaming, and what selective attention does, and especially spatial selective attention, is it helps you parse out where the different sounds are coming from, and you're able to identify the voice and maintain attention on that voice. And this is a partnership between your peripheral nervous system and your cognitive system. And really what we focus on is the different types of attention that you can use in this situation. So I focus on top-down attention, which is basically, so I guess I'll tell you what the other ones are. So bottom-up attention is where your attention is just grabbed by something that's salient. So the baby is crying in the background, you pay attention. Object-based attention is basically, I'll just say it's a skill that you can maintain on a voice. And then top-down attention is really your volitional desire to pay attention. So imagine you're studying, there's a lot going on in the background, your top-down attention forces you to focus. So I studied that using EEG in an example kind of like this. So I have subjects, human subjects sitting in a booth, they're listening to say 3 different sounds coming at the same time from different sources. And I tell them to either attend to one voice or switch their attention quickly to another. I won't get into the details, but this is basically what it would sound like. And imagine that these sounds are coming from 3 different directions. Unfortunately, on Zoom, you can't do that spatial listening. So you can hear it's the same voice saying different iterations of ba, da, and ga, which are kind of ambiguous phonemes. And the job of the listener is to identify the order of the ba, da, ga in the attended direction. So sometimes it's focally, so that's the black trace, and sometimes they're told to switch their attention to the red trace. And without going into too many details, without going into too many details, the EEG traces show that in this group of people, I actually had people who have diagnosed ADHD and people who are neurotypical do this task. And we found that the EEG traces between control subjects and ADHD subjects were vastly different. So without getting into too much detail again, we can see that the control subjects, depending on the traces or the different conditions, depending on the condition, they flexibly switch their attentional approach, whereas the ADHD subjects have almost the exact same responses no matter where they were told to attend. And when you quantify this, we actually found that this neural response, which we've quantified on the x-axis, correlates to performance at the individual level, which is our y-axis. And what we found, very importantly, is that the individual differences, so the spread of information that we see here, correlate with performance on the task, and that effect is stronger than the group differences. So said another way, the different variability in the population to do an attention task is actually more important than the difference between ADHD folks and neurotypical folks. So that's really inspirational to me because it means that we need to study more about everyday functioning in people, not just disorders. So why do this? As I just said, I'm interested in the fundamental brain science of selective attention. Can we find more neural correlates? And what are these individual differences? And are they more important perhaps than what we call group differences, which again, these neural responses are really important for diagnostic and prognostic information. So all of my work is just like super interdisciplinary, and it's really exciting. And we're gonna be doing a lot of this during my postdoc. But what about inclusion? That's what we're here to talk about, right? So I'll just tell a very quick story. My brother, grandmother, mom, that's my PI who's over there next to me, and my cousin Leslie visited my lab when I graduated Boston University. And my cousin Leslie in the green hat said, "You all should do an EEG experiment on me." And I realized that I could not even do EEG on my own family. And it was really heartbreaking because this is something I worked so hard on. I was 4 years into my PhD by the time I had to transfer to CMU. And it was just kind of heartbreaking that I hadn't realized that there wasn't a lot of inclusion in this field up until then. So, and actually, when I wrote a grant about this, the biggest critical feedback was that I had 0 Black people in my sample for the ADHD project I just showed you. So thankfully, I was able to connect with Arnelle when I moved to Carnegie Mellon. And now I'm working at the intersection of all of these issues. What, should we care about individual differences? Should we care about heterogeneity in our phenotypes? All of these things actually do fit together, and we need to pull apart them because they're all confounds of each other. So now I consider myself an ethicist. I'm a neuroscientist, I'm an engineer, I'm an educator, but I'm an ethicist. So Arnelle and I, along with Pulkit Grover, who's our PI, wrote an ethics blog for the Emory Neuroethics blog called Towards True Equity in Neurotechnology, where we spoke about some of these issues broadly and within our own work. I'm currently working on a manuscript called Identifying Scientific Oppression in Psychophysiological Methods, where we're highlighting EEG and fNRIS, but we're also talking about skin conductance recordings, which also have a bias issue because Black skin is different than other types of skin. And we have all these other future endeavors, including collaboration with Arnelle, with Dr. Grover, with Dr. Wood, who you all saw speak yesterday, and Dr. Kanerstorfer. And it's all really exciting work. It's a kind of an all hands on deck situation across the globe, but certainly at Carnegie Mellon, it's a very exciting place to be. So yeah, it's interesting how my life up until this point kind of set me up for caring about these issues from the STEM education pipeline point of view. And now it's interacting with my actual work in auditory and cognitive neuroscience. So thanks for your auditory attention, and I'll answer questions later.
Thank you so much.
Felt like I flew through that, but we did it. Okay.
Yeah, we got that. I loved it. Okay, last but not least, Dr. Achuta Kadambi, if you'd like to share screen.
Great. Let me share my screen. So in contrast to Dr. Kwasa, my talk is mostly visual, which I think is okay for Zoom. So let me go ahead and share. Okay. So I'll try to keep it equally short. Please accept my apologies if I run slightly over. So does anyone recognize this picture by any chance? Many of the panelists are a little bit, definitely look on a little bit on the younger side. I myself am a little too young to remember this, but back in the 70s and 80s, 1970s and 1980s, now we need to add the 19 there, but back in the 70s and 80s, this was very common in pharmacies in the Western world. And what it is it's called a Shirley card. This is a card used to calibrate the photos. Back in the day, we didn't have cell phones where you could just snap a photo. You'd have to take a picture and then go develop it at a pharmacy and then get the photo out. When they developed the film, they had to get the colors just right. And for human skin, they used a certain kind of test image that they tested was rendered correctly, and that was called a Shirley card. It was a picture of a Caucasian lady, and the feeling was if the Caucasian lady's skin looked good if the photos kind of matched the Caucasian skin tone, it was therefore a good photograph. Now the problem is that there's a wide variety of skin types that are out there, and if you set an exposure time or if you set the brightness level, that works for somebody with lighter skin, it's going to make somebody with darker skin kind of look a little bit grayed out, right? The face won't come through properly. And so you would have people of color that would very often go to the pharmacy, they would calibrate it, the images with respect to the Shirley card, and then they would get out images that were unusable for people with darker skin. And so this Shirley card has been a motivating example for me for a number of years. And that brings us to kind of the topic, which is the physics of visual diversity. Our appearance, when we talk about things like, for example, racism, it takes many forms, but one form it takes is based on how we look as people, and that distinguishes us. And there's a certain physics behind what characterizes the differences in how we look. At the first level, it could be something like melanin, for example, that gives rise to some visual differences in our skin. So before I start, just want to mention that any work that's presented is really thanks to my group and the team I get to work with at UCLA. So the goal of our group is broadly to teach machines how to see. So this is a classic example of a computer vision problem where you have like a bunch of self-driving or cars, and you might think of this image on the right as being seen by an autonomous car. And the goal is to draw these kind of bounding boxes around objects that you see. This is kind of like computer vision 101 for those of you who don't work in this particular sub area. But basically, you take a bunch of objects in pictures and you draw bounding boxes. You have a machine that draws bounding boxes around them. Now, this is actually a very challenging task to do. By some measures, about 70% of our brain is devoted towards processing spatial information. That number is a little disputed, but we like to use it in the field of computer vision because it lets us make that snazzy one-liner that kind of vision is the gateway to AI, that visual processing is very difficult, requires a lot of the brain, and it's something that is really that gateway to getting us towards AI. So for the moment, let us assume that AI can be abstracted as drawing little bounding boxes around cars, all right, or objects. Now let's look at why this problem is hard. Here's a chair. It seems like if my goal is, given this image in the middle, I'm going to ask you to find the chair. So I'm going to ask a machine to tell me exactly where this chair is in the image. And I'm going to give the machine also a template of what a chair looks like. So a chair looks like this, and I'd like you to go and match it in this image. All right, so this doesn't seem too difficult. What you can do is take this little template that you have and slide it along every location in this particular image until the colors match up. And it's going to match up kind of roughly in the center. So that's kind of this output on the right where you take this red patch, you keep sliding it along, and then where it matches is right in the center and you get this bright spike. So this seems like an easy problem. I've now localized the chair. But unfortunately, computer vision is not a solved problem. And I'm sure many of you can guess why. And it's because chairs don't always look like this template, right? You have chairs that look like this or chairs that look like this. And if you simply try to go and match this on an unstructured scene, it's pretty much kind of garbage, right? An elementary signal processing approach, similar to what Dr. Kwasa was mentioning about signal processing. In this particular case, it won't really cut it. So visual scenes are really diverse, and that actually is the underpinning of our technical domain of computer vision, is how do we make scenes scale to diversity? For example, in this particular case, we have diversity in chairs. Now, diversity can be seen in some ways, visual diversity, to have a physical root. You can look at essentially how the light and the object and the camera start to interact based on the material properties of the scene. And so that's kind of the goal of our lab at UCLA, is we look at diversity across different scenes. For example, you might have smoke and you might have adverse weather that's obscuring kind of what you want to see, for example, search and rescue. You might have transparent objects here that play differently with light. And of course, you have different people that also have a visual diversity amongst them. So in this particular case, I'm just going to go for 1 or 2 more minutes. I'm just going to give an overview of the visual diversity of people using, for example, skin as an example, as well as others. So in a recent paper we had in Science, what we looked at was essentially the areas in which a medical device, for example, whether light-based or not, can be biased. So on the one hand, on the left-hand side, there's a physics of the bias, right? For example, if it's light-based, how will it play on darker skin? There's the computation of bias. If you have a imbalanced versus a balanced data set and you do AI and machine learning on that, that's a different type of bias. And then finally, there's an interpretation of how we study this. So many of these forms of bias, I think, have been pointed out by excellent scholars, such as the ones that we had just in this panel right before, pointing out, for example, on hair and the physics, the geometry of the hair and how that leads to differences in sensing. So one of the ideas in the paper is that there's this minority paradox, what I kind of call a minority paradox. And it ties into what Dr. Kwasa was mentioning about running a study about trying to recruit subjects, potentially of color, but I think the example that she made was Black subjects. And so minority samples sometimes pose a paradox for these devices. Because the devices have not been designed for minorities, sometimes the sensing is just harder. For example, cornrows was an example. So it's inherently harder or more difficult to make the sensor work on minorities because it's not been designed for them. But on the other hand, we also don't have minorities to test on because by definition, a minority is a minority. There are fewer of these subjects that are out there, even in the absence of any form of discrimination. So this leads to a paradox of how we solve this problem, and definitely we need to have constructive efforts, and I look forward to learning from others on the panel as well on how we can make that happen. I'm going to end with one example result of a technology that is being commercialized in the clinic, but it's not fully ready yet. Here we have a kind of a line of research that uses computer vision to basically look at pictures of your videos of your face and estimate your heart rate. So for instance, if you look at this subject here, this Caucasian subject, you have a video here that's estimating based on slight color fluctuations what the subject's heart rate is. So you can do essentially heart rate from video for telemedicine. Now, if you look at the ground truth heart rate with a physical device, it's 59.5 beats per minute. And if you look at the prediction, it's actually very close. It's about 60 beats per minute. Now, on the right-hand side, we're going to look at a dark-skinned subject. And on a dark-skinned subject, it's very difficult to pick up color variations. As we all know, those of us with darker skin, we have the bittersweet luxury of not being able to show our blush, right? Which sometimes helps us in social situations, and definitely in cases like this medical device, it's not helpful. Actually, we want to see the blush, and we want to see the blood flowing and pick that up. And so you can see that right now you're about 10 times the error on a dark-skinned subject, right? And this also holds true for things like temperature measurement. We're finding out some of the methods they're using to actually estimate your temperature, especially in COVID-19 times, which we do at egress, some of these are a little bit off depending on the reflectance of your skin. So long story short, this example is pretty stark in the sense that you have a device that's ready to ship on certain skin tones. It's clinically accurate. And you have a device that's not clinically accurate on darker skin tones. And I can tell you there's been a push to commercialize this technology, particularly in more homogeneous areas of the world, but it's not fully ready for all skin types. And so that's kind of an open question of how we define readiness or technology readiness level based on who it works on. So I'll stop here. Thanks for your attention.
Amazing. Thank you so much to each of the panelists. My brain is completely racing right now, and I've been writing down notes about what each of you are doing at the moment, what you've studied beforehand, and yeah, I'm ready to get into the conversation. So one of the questions we'll start off with is, we know that within neuroscience, a lot of the recordings are done on the scalp. And so I just want to hear from you guys about what are some of the main issues with acquiring signals from the scalp. Maybe if we go to Arnelle, first of all, because I know you've touched on it already, and we'll see, we'll go from there.
I was still muted. Okay. First of all, shout out to the other two presenters because your work is just like amazing. And I'm really glad and grateful to be part of this group. But back to the question. Some of the issues are just like, okay, so there's no systematically like, there's no systematically efficient way of doing this right now because not everyone is educated on how the hair works. So like I actually had an EEG done on me in Reston, Virginia, which the DMV area has a lot of Black people. So I think the medical staff have more experience dealing with these things and they kind of learn through doing, right? So I actually had a great EEG experience with a white technician. And I was like half awake, like asking her, but I think just her understanding, like, or having experience with my hair type helped her. So for me, a Black woman, I know that there's a certain type of way that you part through my hair, or you can't expect me to straighten my hair before a meeting because on the way there, just me sweating, walking to the appointment, my hair might, go back to the front. So sometimes clinicians will ask you to do things like straighten your hair, or in really bad situations, they've shaved people's hair, and like that would break me as a human. So like that's just too much. So those are some of the issues with hair. Long story short.
Yeah, and I can add to that, like, even in general, if we're talking about straight hair or who we traditionally think of as users of EEG, EEG especially is a really hard and noisy environment to work in. Like all of these neurotechnologies, the challenge is how can we be non-invasive and still infer information from the brain, right? That's like the main goal. And when you're dealing with MRI, it's super expensive. You have to go into this coil. Obviously, a lot of the research that we do in Black and Neuro is like molecular, it's like animal models and things. So using EEG is kind of a state-of-the-art technique in the clinic because it's this non-invasive thing that you can use on humans, but people don't like it. And we only use it for like stroke and certain neurological conditions because it's noisy. It's just inherently, the instrumentation itself has noise, the brain is noisy. And if you don't have the engineering background, noise is just information that you don't care about that is not a part of the signal. And we even quantify that with the signal to noise ratio, or SNR, which if you're an engineer, that's like the bread and butter of everything. You're trying to increase SNR. So even with straight hair, I'm putting on the cap on my research subjects and I'm going in and adding gel, adding conductive paste, moving around the cap so that that contact is maintained with the scalp and we can have an impedance level that's low enough so that we can actually get something done, and we can actually get the cleanest signal without as much noise as possible from the scalp. So it's a challenging modality anyway, and then you add on the hair issue. Then you add on, in the case of optical technologies, you add on melanin, you add on these issues. So it's not to say that this is like a huge oversight. Like there are other issues with EEG in general too. Just want to add that.
Yeah, brilliant. So I just wanted to feed in one of the benefits of the EEG, because I'm sure a lot of people are wondering, why are you guys using this technique right now, right? But it has really good temporal resolution. Okay, so other techniques such as fMRI have very poor temporal resolution, and what that is to do with time. So with EEG, when we see certain spikes in the data that we get out, it's very close to the actual time that is happening within the brain. And whereas other techniques, you'll get a 1 second lag, a 2 second lag, which might not sound like a lot, but is a lot when you're researching. Cool. So just kind of going on from that, I wanted to discuss, and you kind of touched upon it, Dr. Kwasa, where you kind of stated that these technologies are used for stroke and epilepsy research also. And I just want to talk about the potential consequences of not being able to acquire EEG signals from Black people who have like coarse and curly hair types.
Right. So how do I frame this? There's multiple issues here. One is that I'm not a medical doctor, and so I don't know as much of the stats about neurology in general. But this is a medical issue across the board. It's not just neurology. It's not just neuroscience, where we have a race-based medicine system, right? And we've long known, and this is a part of some of my background work, like we've long known that there are these like racial disparities in healthcare, right? And the sources of it are multifaceted. It could be that African Americans or Latinx folks are in these underserved communities where there just aren't enough clinicians. It could be that there's bias in the people who do see those patients. And then now we're seeing that there's bias in the technologies themselves, right? So there are all of these issues coming together. And if we add on another issue, which is that, you know, your hair gets in the way or your skin color is a part, it's just like such an uphill battle. And I think that's why I'm so vocal about this. It's embedded in our medical system that we have these issues, right? And so I don't know the exact numbers. I'll be upfront with you. I don't know the exact numbers of the racial disparities in neurology in particular, but it stands to reason that if communities of color in this nation are disproportionately impacted by pollution in the area, by not having enough educational opportunities, like all of these kind of things that affect our actual mental health and physical health, then we're going to see larger incidences of stroke, which has to do with diet and things like that. You're going to see misdiagnosis of epilepsy. You'll see people maybe having seizures and being, you know, mistaken as a psychotic break, and maybe the police are called. I mean, there's so many intersections and issues that go with this. So it's a huge import that we even deal with the physical realities, because at least we can have a fair technology to work with, even if the doctor is biased, the person can't get into the clinic because of the backlog, all the other issues. Let's at least get rid of the physical reality. I think that's my position on it. I got there. We got there.
Yeah. No, that's 100% it. You're preaching right now, because I think it's exactly what you said, right? Why have we got technologies that can only be used on a certain subset of the population? And this isn't just in neurotechnologies, like you said, we see it within all aspects of the medical and even imaging world. So you're completely,
right.
Yeah.
And I'm going to add again and amplify what Dr. Achuta said. I'm sorry, I don't know how to pronounce your last name as well. But in the technological space, there's all these AI fairness and inclusion issues too, right? So really the framework I like to think about, especially with neurotechnologies, is that we have these biases in medicine and in care and in all that. We have biases in technology. We can see how there's like predictive policing and all of these issues. And even, you know, I won't get into the detail, but so we have these two huge fields and now they're coming together. If we have bias in both, then it's probably not additive. It's probably multiplicative, right? So it's just, in my opinion, almost a crisis. It's something that we should be talking about. We should be talking about it. We should be working towards it, and we should be getting everyone on board, not just the Black neuroscientists around, right? So
100%. Kind of going off of that, and I'd like to go over to Dr. Kadambi, is thinking of kind of that joint effort between neuroscience and technology. Where do you think are the efforts best suited in terms of focusing on the physical equipment, or focusing on kind of post-processing and algorithms? What are your thoughts, especially in terms of light and fNRIS and that kind of area of things?
Yeah, I think, following on what Dr. Kwasa said about the importance of the, correcting the physics of the problem or addressing the physics of the problem, I think all of these are important. I think that the correct answer, I guess, would be that all of them are important, right? We should consider biases that occur in any step of the pipeline. But another way to kind of, if we were to press to give a more undiplomatic answer, I think we should also kind of put our efforts where we don't have as much representation or work in that area. And I think the physics of the problem are actually often less apparent. I think we've had many excellent colleagues, courageous colleagues in computer science who have rightly pointed out the biases in algorithms and data sets and so on. And this is widely covered now, thanks to their heroic efforts. But the biases that are inherent to us in the laws of physics, I think they are also very exciting. Some of the things that were mentioned in this panel earlier, I think are things at the root of the problem, if you think about it, right? We start with the physics of the world, then we sense that with technology, and then we end up interpreting that maybe with computer science and algorithms. And so if the root of the tree is not healthy, it might be a little bit difficult as those biases propagate. So there is a trend in computer science to say, okay, if my sensor is biased, no problem. I'll have some post-processing that goes and corrects for that bias. And there's value in that research, but maybe if it's possible, we should see if we can correct it at the root.
Fantastic, thank you. I'm just going to jump to some of the questions that I'm seeing in the chat because there's quite a few in here. So I think it would be good if we can answer some of the audiences. So we have one here that says, thanks so much for these great talks. I was wondering if the panelists have an opinion about making research more inclusive by adopting open science practices. So that's publishing, open access, sharing data and methods and ways that can be used by others and reutilized.
I'd like to start off. I really love open source, however much I can, open source everything, because sharing information in community in general is what creates like a togetherness. And I think that doesn't stop with science, So I think that's one thing. I work at a startup, so sometimes open source can be hard because it's like antithetical to to capitalism, but I try to be as open source as I can. The paper that we wrote, we put it in a journal. It was a conference proceeding, but we also did a preprint, which I'll put the link to that in the chat when I'm done with this question. So things like that, where you do an open source preprint so anyone can see, your work without having to pay a fee to access it. Or things like Black and Neuro, like, we've reached out about doing collaborations where, we'll be sharing data and we'll be, talking back and forth. So I think things like that, like I'm definitely going to be reaching out to as many people as I can after this. And I think just having those connections and networking and just sending data sets and information when you can it doesn't cost you anything, for real. So.
I can add, I've been thinking about this kind of all summer a little bit, just about how there isn't a lot of data about a lot of these issues that we're talking about. I mean, sometimes we're coming up with solutions to this problem that is very anecdotal, right? And we don't actually have data that says, okay, how many people were excluded from this study because of their hair? People don't write down that data as much, right? The NIH tries to have these mandates of, okay, have X many people, women or children or whatever in these studies and give us an excuse for why not, IRBs as well. But even with those rules in place, no one's collecting the data on it to make sure that like, okay, well, you did have 20 Black people in your study, how many of them had coarse curly hair, that type of thing, right? And so I think data sharing is super important, and just to even understand that, right? Like because there's been no concerted effort to figure out that data, what if 100 labs across the US doing EEG in their next study, the one that they're going to do in the next semester, reported that into a big repository, and we actually saw what the impedance levels were for coarse curly haired individuals, what's the SNR for your EEG or fNRIS signal when you use it on, I mean, that would be such a powerful project. And I've been literally in my head all summer about like, how can I make this happen as a postdoc? Or even I was talking to an expert at NYU all about skin conductance recordings and kind of the biases there. And how even like, there's this idea that Black individuals can't do fear conditioning paradigms, like their responses don't show up because their baseline is different. And like, what if, again, we have national repository where we showed the baseline level of all individuals with, you know, the Fitzpatrick scale, whatever, 7 or 8. I don't know the numbers, but that would be really powerful. So I think data sharing is super important, even for the basics of like, what is the problem that we're dealing with? Because we don't even know in a documented, citable way what the problems are. We just know anecdotally. So it's huge, and it's something that I've been thinking about and really excited to do. And hit me up. I'm happy to like collaborate on it.
Exactly what I was about to say. You know where the details are.
We've been up here all day. Yeah.
Brilliant. Another question we have here. Could the SIBO EEG electrode design be translated to optos in fNRIS?
That is the exact answer. Which, yeah, we're looking into it, and I will leave it at that. But on a science level, I think, like you were saying, Dr. Kadambi, just understanding the physics of the problem really does help. And I think, like, again, I feel like the crux of my research at this point is that parting the hair is really like, that right there is the sweetness. Everything else is kind of like an addition to the meal, right? But the parting of the hair is the crux of what you need to do. And so I think that can be applied to any technology that you're using on the scalp. And I feel like if you get creative with what you can do with that, like, it really opens up what you can do in the space. So, but I don't know, does anyone else have any thoughts?
Yeah, I'll just back up, Arnelle. It's cooking. And Dr. Wood even alluded to it yesterday. Like there's a collaboration for all of this. And I'll just say for fNRIS, you all probably already know this, or maybe not, I don't know. And Dr. Kadambi kind of mentioned it too. Like the problem with optical technologies is also your skin, right? The melanin. And so, or maybe, I don't know whoever mentioned it, but yeah, so with fNRIS, the optodes, you need double the optodes, right? Because there's like an input and an output. So the light has to go in, the light has to be received. So you're doubling up. And so that leads to high density problems, which means hair is going to get in the way. But also if it's an optical technology, your melanin is going to matter. And so there are probably both hardware and software solutions that need to be adapted for that. And that's like, I hope there are tons of other labs doing it too. Obviously we work for a company that we can't say all the things.
You know, to follow up your point, Dr. Kwasa, I think there's also, melanin is definitely one aspect, definitely very relevant to this conference and session. But there are others, such as women versus men. There's actually a substantial difference in the skin morphology between women and men, where, not to make this literal at all, but, and I mean this in the literal sense, is that women have thinner skin than men. And men have thicker skin, right? And so how does that impact the quality of measurement, the quality of wound healing, you know, how we adapt to these things? Age also plays a role in how the morphology of skin changes.
Thank you. I'm learning so much from you guys. I can't wait to look back on this recording. I would also just like to explore, so we've got a question here, and it's of particular interest to me as well, but it's about the future of fNRIS. So if anyone would like to take that.
The future of fNRIS research. So, okay, let me orient the audience to what fNRIS is, and maybe I can come up with an answer in the time that it takes to explain it. So fNRIS, I think of, in a very reductive point of view, as a portable MRI. It's not quite that, but as you might know, the MRI, functional MRI, you go into a facility, it's very expensive from the researcher or hospital's point of view. It takes time and effort. fNRIS is using light to still get the bold response. And the bold response is like blood oxygenation. And so it's kind of an indirect way of finding out if the underlying tissue is activated in response to, say, some experiment or some, stimulus, right? And so whereas EEG is really focusing on the electrical activity coming from the scalp in like the summation of coordinated neural activity, the bold response is really how much oxygen is being used up by the underlying tissue to do the task that you're doing, right? And so a lot of times fNRIS is about tracking relative changes in hemoglobin, in hemoglobin really, versus oxygenated versus deoxygenated hemoglobin. And so the future of fNRIS is anything that you can do with an fMRI, you can do with fNRIS, right? And you can do it hopefully across the whole scalp. I think right now the state of the art is focusing on a region of interest. So for instance, with me and my collaborators in the auditory context, we're going to be paying attention mostly to kind of the, temporal auditory cortex area, right? Or maybe even the frontal areas because we're dealing with cognition. But if we can get those high density opto placements put up, we can track the entire brain. And what's really happening physically is that you're getting infrared light being injected into the brain, and it's going in, being scattered and absorbed throughout the tissue in the brain, and then it comes out and another opto picks up that. So that's kind of how it works. So the future is that we can do so much of this kind of spatial location in the brain type of science, whereas EEG, you maybe have at maximum 128 areas on the scalp with great temporal resolution. With fNRIS, really what we're looking forward to is having incredible spatial resolution, and we'll be able to see what kinds of areas are activated during different tasks. So for me, it would be you're listening to someone from the left or the right. Okay, what parts of the brain are really activated and lighting up, right? So it's just really it's unlimited, honestly. That's my perspective. I'm not even going to get into too much detail.
Thank you. Yeah, I'm particularly excited for fNRIS because I combine EEG with VR at the moment, and of course electrical interference and things like that. I just like to step over and not have that issue anymore. So yeah. You guys can keep working on it.
I mean, you need the temporal resolution, you need the spatial resolution. My lab is also doing, I get the word stimulation and simulation mixed up. We're doing stimulation too. So transcranial, either magnetic or electrical stimulation. In particular, the electrical stimulation, just like EEG, is portable, right? So you can put these, different electrodes down and inject current into the brain at safe levels, of course. And what would it look like to have concurrent stimulation, EEG tracking for temporal resolution, and fNRIS for spatial resolution? Now you have a full, complete view of the brain. You have causality with the stimulation. You just have every aspect that you need. And that's really the future, is portable, non-invasive brain tracking for disease and for healthy individuals. That's the state of the art. That's what we're looking for.
Great. So just keeping on kind of topic with fNRIS and kind of uses of light, I would like to explore why is there such a difference between black and white skin. So we've spoken about melanin, but is there like any additional insights that you can provide to us? I think specifically, Dr. Kadambi, I know you've done a lot of research around this and have some fantastic papers.
Yeah, so I can chime in briefly here. In short, we don't know. We don't know really what the differences in skin types are, because in order to get that information, we need to have a study that is grouped across demographics and skin and age and so on, right? Everything I mentioned about age and skin, they're largely based on simulation models and some very sparse morphological studies on cadavers and so on. It's a really hard problem because now I'll piggyback off Dr. Kwasa's example about the Fitzpatrick scale. As I understand, it goes from maybe 1 to 6. And so you have these 6 different groups now of skin color. Just as a primer, the Fitzpatrick skin tone scale is, first of all, I don't think it's a good representation, but it's the best thing we have right now. It's better than nothing. Let me put it that way, because nothing is actually the status quo. So at least the Fitzpatrick is a little bit better than that, in the sense that it kind of divides your skin into kind of really light skin, like, you know, white, you know, like a darker white, and then brown, and all the way down to really, really dark black skin, right? That would be Fitzpatrick 6. So the Fitzpatrick scale requires you to, if you want the same statistical power, let's say I have a study, a lot of these studies on medical devices will have maybe about 30 or 50 subjects, right? So if you have a study with this amount of subjects, which I understand how difficult it is to get subjects, now you want to group it by their skin type, you have to divide that by 6, and you only have now, let's say it's 30, you only have 5 people in each group, and they may be different genders as well. So maybe half that as well if you want to control. So now you're trying to compare like 3 different people in these different categories, and it becomes very hard to draw any conclusions about how skin is different using this scale. So to solve this problem, what we really need to do is we need to put more resources. We need to fund scholars, projects like what Dr. Kwasa was mentioning, about the hair, for example. That requires a capital expense, right? That requires funding, a time horizon, the ability to recruit a sufficiently large number of those samples. And I'm hoping that's where the kind of academic and funding communities are going, is to support these types of studies so that we can actually answer and draw these questions. Because right now, most of what we have is either simulated or uses kind of let's just say not super correct ways to classify different demographics. That's kind of my opinion.
Thank you.
Yeah, Arnelle and I were talking about this the other day. We don't even account for, of course, there's skin types between each of the I think there might be 7 actually, different like skin tones. But then there's like, you know, what is it called? Arnelle, help me out. Like the think about Fenty. Like, look at all those colors there are for makeup. And for women, that's very intuitive, right? Because we know that, well, not women, people who wear makeup, right? Go ahead, Arnelle. I don't know.
Oh, yeah, no. I like to think about like scientific problems in very like regular day ways, because it just makes it easier for me, and it also makes it easier to translate the information to everybody. And so when we were talking about this, I was like, you know, Rihanna really changed the game in the makeup world, because before, and it's like literally the same problem in the makeup world as it is in the science world, right? Where like before the Fenty line came out, I was the darkest foundation that you could purchase, maybe. Like if you were in a Black neighborhood, maybe you could find my shade. And like, then she came out with a 35 line, you know, a 35 shade line with sub undertones. And it's like, when you look at things like that, it's a very basic thing, but like she classified skin tone for us with undertones, you know? And it's like, if you can translate that to the optics side or translate it to the physics side, whatever side of physics it is, then you are, you know, one step closer to solving the problem. So Rihanna, if you want to fund Black and Neuro, you know.
I mean,
you know, I'll just pick back on that, Arnelle, in the sense that it's not just makeup. Like I live in California, so I wear sunscreen. And just this morning, actually, it's kind of like lunchtime in California. So just like a few hours ago, right before this talk, I was running outside, and I used sunscreen. And then a friend of mine who I know, so I know he was joking, but said, I'm playing reverse racism today because I'm playing whiteface. So, it's like, it's an innocuous remark, but that's another one is that, and I'm probably preaching to the choir here in the sense that folks that use sunscreen, if you use any mineral sunscreen, it's going to leave a white residue. So they have, there's a nice new company. I don't know if other people use it. Is it called Black Girl Sunscreen?
It works.
Black Girls, I think. Or I think you had it right. I'm sorry.
Also, the Neutrogena line works pretty well too. Sorry.
A lot of the Japanese lines work really good as well. But
can I also I just wanted to add one thing. Like, I really feel strongly about this, but I just feel like all darker skinned people, whatever racial group you belong to, should be working together. Like, I had Indian friends in high school who also had the foundation, shade problem. And like, this is something that we should all be advocating for because it affects all of us. And when we do come together, you have, so many different sides of, or so many different angles to attack the problem from. And I think, further amplifying of each other's struggles can really help bring faster change, I think, than doing it apart.
I have two really quick points on top of that. Like, yes, we're gonna all, like, first of all, my friends call us the global majority because when we think about white people, they call us the minorities, but we're a global majority. And in the grand scheme of the world, fewer people in the world are white than not of white, right? So if we come together, that's definitely a thing. What was the second point? Man, the way that my ADHD is set up. Let's see. Oh, I was going to kind of put a little onus on the viewers who aren't in this field. Like, I'm an engineer, I'm a neuroscientist. So as a neuroscientist, I'm thinking, okay, how can I like use my engineering skills to affect change, right? And I'm in a perfect position because I know about Blackness, I know about but all of us can do something, right? Like, I think people in the leadership at these organizations, like IRBs and foundations who are giving grants and even journals, it's on them to say you need a certain number of Black subjects or X type of subjects, right, in your pool for us to publish your study or to fund your study or whatever, right? And that will push people to be more urgently thinking about equity issues, right? But even in your own practice as neuroscientists, if you're a human EEG, like human physiological scientist, like really think about who you're like putting into the lab. Like, I saw another question in there about best practices for when you don't have a Sevo clip and you're still doing EEG on Black hair. Like, there are things that you can do. Be mindful of your own labs. Like, what are you all doing to offset this issue? And you don't have to be an engineer to face this. And I have another point, but maybe it can come up later, just about how like the lived experiences of racism also affect brain signals and how like racism itself is an issue, not just the physical, not just the bias, the actual lived experience changes your brain. So it's on all of us to make neuroscience a more equitable space. And it's a kind of all hands on deck type of situation. We need the physicist finding us what is the base truth. We need the neuroscientists recruiting properly into their studies. Like, I was just in Philadelphia. It's 40% Black. Are all of the studies at Penn with 40% Black people to reflect the area? I bet you not, right? The IRBs, the institutions, the foundations, all of us have a say in this, and it's always going to help the greater good, right? Because we're actually going to get to the truth of how the brain works if we get everyone's brains online, right? So I guess that's my ramble. That's what I always kind of harp on. It's not just on me, the person situated perfectly. It's not just on my panelists here who are like world experts in this, right? Like, it's on all of us. So that was my little like Hail Mary.
One last thing, sorry. And they have to give us the money to do it. That's all I have to say.
Right, the foundations should 100% be on board for this. I'm thankful for whoever put in the questions, that funding opportunity. I'm definitely gonna look into that.
Thank you for that.
Thankful.
And just like if you are in the community and you are on review boards, or you know people who are on review boards, encourage them to be knowledgeable about these subjects, because I'm still learning as a scientist. I just got out of my undergrad, so I'm learning a lot on the day-to-day, but I was, applying for grants early on in my career, and I got a lot of feedback where they were like, is this a problem? And I had to start doing the work to show them that's a problem. Or they'd be like, to shift that, if they're asking people to have a certain amount of Black people or people who are quote unquote minorities in their studies, and they know that the current technology does not accommodate that, how are you as a review board going to mitigate that? How are you going to assist the people that are applying to these things in getting, lessening that gap?
That's spot on. And, I feel like even though we're virtual, I feel like we're all facing very similar problems here. Just to follow up that point, Arnelle, and I'm going to turn it over with a more cautionary tale here, like more of a warning. Many of us are junior scholars. We are at 3 different levels of seniority, it seems, on the panel, but 3 slightly different in the grand scheme of things. We have people in their 60s and 70s and so on, who are ultimately our decision makers in academia, right? The deans and then the department chairs and the senior tenure committee and whatever, right? Now, one of the comments that I got, and I don't know if this has happened in your research as well, is that, are you really solving an important problem? Like, is this really that important? Shouldn't you be inventing some radically new technology, not just making it work on a smaller group of people? And that's something we have to plan for. How do you deal with that, Arnelle?
Yes, thank you so much for bringing that up, because I've had that happen. I am wearing a May the Swartz Be With You shirt. It's the Swartz Center, Entrepreneurship Center at Carnegie Mellon. And in that, I took a few classes there. They taught us about customer discovery interviews, where basically it's like a conversationalized survey where you're asking people, what are the issues that you find in this problem? So, in this case study would be like, what issues do you have with hair? How many Black participants have you, given away? And we had to kind of collect that data ourselves, or ask other people to collect that data if they had it. And I think, like, by creating your own tiny surveys, even if it's not 100 people, but by kind of laying that groundwork, and then also using spaces like Black and Neuro as a connective network where I can share that information with you now, or you can share that information with me, like that can really help move the space. And then also, a lot of us have PIs that are very supportive. Not everyone, we pray for y'all, but a lot of us do. And if you do, have a conversation with your PI about spreading this, these types of specific messages with their higher senior members, because they have more access to those higher up people. So I think a multi-layered approach usually, can help.
One thing that I really appreciated from Dr. Kwasa, which I think you guys are kind of pulling back to, and something that can easily be implemented, is including that rejection rate, telling us why people were rejected and how many. Because you see people coming in for EEGs all the time, and they might have in braids, they might have in a weave, they might have on a wig. And that's because that information wasn't supplied on the flyer, but also, like, a lot of subjects just come because they're like, okay, this is cool and I want to participate, but I don't know actually what an EEG is. I don't know what an electrode is. I don't know what it needs to do. I don't know that it needs to be on my scalp. There needs to be contact. And having these documented is something that can be so powerful and so easily done, but also turn around and shown, kind of like showing them a mirror and saying, look, this is a problem and here's the statistics for it.
Yeah.
So,
sorry.
No, continue.
It's just making me think about how in the world that we live in, not putting my opinion out there, but there's a lot of, so first of all, the world runs on peer pressure and the world runs on capitalism. And so peer pressure, meaning that there's actually multiple tech companies are right now caring about these things. They're caring about computer vision and fairness. They're caring about especially the ones with the VR type of thing. They're interested in using EEGs and fNRIS and things like that in this commercial space. So there are calls out from multiple tech companies about the technologies that we're developing here, right? And so if you had told me that 5 years ago that this would be the truth, I wouldn't have believed you. But because of George Floyd, because of the big, I call it the race riots, the race wars of 2020, you know, and don't mean that I'm taking light. I'm not taking light of it, but you know, the world is getting there. And so while there is a lot of pushback, it is false to think that just because the dinosaurs in the field are gonna like retire and become emeritus and we'll run it. No, the ideas that they have are embedded throughout the academic pipeline. So we really need to start using the people who get it and have them peer pressure academia into getting it, right? If Facebook and Amazon and Google are starting to care about these things, even if it's lip service, we can use that to our advantage. And then I was just also thinking about capitalism, like, I don't know, I just recently had how do I say this diplomatically? I had a situation where I was just trying to think strategically on why like inclusive technologies weren't prioritized over a more like general technology. And looking at kind of some market research, it turns out that people just underestimate how impactful, how much money you can make off of solutions like Arnelle's, for example. And so people just really being mindful on the critical lens that they put on data and like asking the right data questions is going to help, because if the market shows that there's actually a large number of epileptics who are Black who have to cut out their weave every time, then maybe from a money-making standpoint, we can say like, hospital, you're going to get more patients because you're known in the Pittsburgh area for doing well with Black patients, for example. So I think you're right, Dr. Kadambi, we mustn't kid ourselves, right? We should deal with the reality that there are a lot of people who are against this stuff and just fight right back in the language that they understand. Okay, now I'm done.
No, thank you. Honestly, these snippets, I need them to be condensed and I need to like feed them back somehow is fantastic. But kind of going on from that and snowballing on, I want you guys to kind of discuss, and because there will be possibly some people in the audience having that question that's kind of like, okay, I'm here at this panel and I'm listening, but how does making technology inclusive for kind of these minority groups, and how does it impact performance for everyone? How can it benefit me, myself? And I think you're right, Dr. Kwasa, and kind of sometimes you have to talk their talk, and sometimes that's money. But for other people, that's having more people included in their research and having more wholesome research and more accurate. So yeah, I'd like to hear your opinions on that, please. Y'all ain't got no opinions?
So you're asking like, what is the impact of having an inclusive kind of?
Yeah. So yeah. What are the benefits? I mean, we know them. I know within this panel we know them, but for others who are watching who might kind of have that wonder and would like to know, what would you tell them?
Yeah, I mean, I don't want to dismiss the kind of have empathy for people of color argument, because to me that's kind of obvious. Like, wouldn't we want to have the best type of care for as many people as possible across this globe? Like, to me, that's reason enough. And when you're talking about, say, Facebook wanting to have a VR headset that works for everyone, yeah, that's a moneymaker. Like, sure, you can omit 13% of the United States population because you're going to get the other, 87%. But when you're talking about human health, it's a burden for taxpayers. It's a burden for all of us, right? When you're not caring and tending to the most vulnerable people who historically in this nation are Indigenous and Black folks, right? So to me, like, you can be in the realm of empathy, and we should talk about we're one global human race and we should all get along. But also it is impacting people's pocketbooks by not caring about this. Like, I have a friend, she's in Boston and she has not epilepsy, narcolepsy, and they use EEG. She has this beautiful big hair, curly, and she struggles every time she goes to the doctor's office because she's wondering, okay, how do I do my hair this time? Or are they gonna have to have me come in again? The more time she goes in unnecessarily for these procedures, the more that she pays out of pocket, the more that the insurance industry, like it's just money and time wasted on all parts. What if that doctor could have more time to see more patients? I mean, it feels like a bunch of degrees of separation, but it's really not. And then I want to put us in a global context as well. So I'm half Kenyan, and I actually have an aunt and an uncle who are neurologists. And they have their own ways of dealing with things. They've actually used braiding before. They usually tell their folks to come in and straighten their hair ahead of time. Ooh, let me hurry up. But this is a global concern. We're talking about nations where there's 100% Black people, more or less, or I guess just less. And what about care for them? What about, I mean, do we really think that we're morally superior in the United States because we're caring for the like majority of the people in the United States? Oh, we're fine. No, like, across the world, we need to make sure that we're dealing with everyone's health, because again, it's going to only affect everybody else if other people are sick. So I don't know, that was kind of wishy-washy, but that's one starting point, and I'm sure the panelists will expand.
Yeah, maybe I'll go next and just follow that up with, I agree that I really liked Dr. Kwasa's point, is that some people are not going to get it, and we need to phrase the benefits in a way that they will get it. Money is, I guess, one of those ways. I think another way is also invention. For example, let's look at Arnelle's device, right, that she's building to accommodate for example, cornrows, just to use an example. She will have to now invent a new sensing strategy and paradigm. And so you can think of the inclusion as a crucible for innovation. Arnelle will invent some radically different method, and this new method could actually be better for everyone. So innovating for these hard cases can actually lead to radically unexpected and meaningful discoveries that could then benefit everyone.
To follow up, I really love that. And I definitely see that in my work and just abroad, like people have always said, we've heard in our communities that when you design for the margin, you design for the whole. And I think that really speaks to it. Like the pandemic has been an example of that. When we want to create, housing for people to eat in, we can all of a sudden do it. But when it's for the margin, for the people who needed it, it's like, oh, we can't do it. And I think we just see instances of that. And also I wanted to bring it, so we've had the global perspective and the national perspective, and I wanted to bring it into a more individual example. Freshman year, I was doing programming homework and we were doing a visual something or other, and I was already struggling in the class. And then the homework was to use this technology on your face and have it calculate something about you. And I couldn't do it. I couldn't do it because it wouldn't catch me. And my friends had the same problem, and we were struggling all night with it, which means we had less time for the assignment. We didn't get an extension, even though that wasn't our fault. And it was, an issue. And when we asked for help about it, they were like, there's nothing we can do. So it's do I have a friend who's white, sit there my entire programming assignment so I can finish it? These assignments are 25 hours. So it's you can't do that, Okay, so we have 4 minutes left. Can I answer the question about the faux locks, box braids, and twists really quickly? Unless anyone wanted to add anything about what we were talking about. Okay, so somebody asked, any thoughts or experiences with participants that have weave or protective style like faux locks, box braids, or twists that don't align with the classical positioning? So this is a really important question. I'm glad you asked. As for my electrode, it actually works between braids and locks, but there's a part of the question that I think was important, aligning with the classical positioning. So I think there's more work to be done about like, how do you get underneath a lock or a braid? But I think it can be fairly easy. Like if you go to your EEG or you schedule it before your retwist, if you have locks, right? You have a lot of space in there where an electrode can fit. That's knowledge that like someone in the community would know, someone outside of the community might not. Or, if you have box braids, there's ways to stick a comb in there and kind of put your finger in there. We've done it to scratch our scalps before. So there's just like ways to get around this hair that if you have it every day and you're intimately involved with this hair, like, as for weaves, that one is harder, especially if it's like a sew-in, because at that point the scalp is completely, blocked off. So that is something that I'm still trying to work through in my head and, work through with my colleagues. But as for those other styles, I think they're not as hard as we think they are. We just have to have more culturally competent information about them. So, yeah.
I'll also add wash days onto that. We can't just be getting an EEG any day and having to wash it right after.
Yeah.
We just do wash day on Sunday and it's Monday now.
Exactly.
Okay.
I'm excited about all of these questions that are coming in, and I'm willing to stay on Twitter and like do my thing on there. I'm happy to do that. I'm sure everyone else is too.
Cool. Yeah. So we'll have Twitter Spaces later on from the Black and Neuro account. So feel free to hop in there, and any of the questions can be asked or answered there again. But just to round off and kind of say a bit of closing, and I'm very sad to close this, but I think one of the questions would really round it off quite nicely. And I understand the importance of this technology, and I'm extremely inspired to participate in research like this, but where do I even start? How do I get involved? It seems so impossible from my perspective. So if you each just have a few words to kind of inspire someone who's interested in getting involved.
I will tell my version of the story of Arnelle, because she was an undergrad who was in this. I mean, Carnegie Mellon is like mini MIT around here. Like, this school is very competitive and it can make you feel bad for just being you a lot of times. And Arnelle was able to say, I have a curiosity, please let me do it. So I would say, if you feel like you have something to contribute or you just are curious, find your allies locally. The only reason why Arnelle can do what she can do is because Pulkit Grover, our PI currently, said, I'm happy to support you. And it was all her doing it, pushing, right? So never feel disempowered where you stand, because presumably you're already in school, presumably you're already doing work, right? So just feel around and use Twitter to your advantage, and remember your why, because if you know who you are and you know what you stand for, then you can find a way out of no way. That's me getting preachy, but I see Arnelle doing that all the time, and she brings up makeup in these spaces with these like super powerful elite people, and she's just being herself, and we are getting places because she's being herself. So I just love Arnelle for that, and I've learned so much from her in my own journey. So that's kind of what I feel like can be done. And then just DM me if you have a more specific question, because obviously there's some logistics that have to happen if you're like interested in engineering versus neuroscience versus policy and things like that.
30 seconds, I will add, know whatever institution you're in, know their policy backwards and forwards. Don't rely on your advisors to know the policy, not in a malicious way. They might not know, and they might not remember to bring certain things up. So when I was in school, I had different advisors for different things. And I took the initiative to look through the bulletin or like the policies, and I would be like, oh, I just found out I can do an independent study doing this research, and it would count for one of my graduation requirements. So please let me do it. And then all of a sudden I'm doing it. So know your way around so you can maneuver, because other people don't have the incentive to innovate a path for you, but you do, because you have to survive. So
right. We're different, so we have to do things differently is kind of what I'm getting from it. Yeah.
So I'll kind of just round that off with maybe more brass tacks. Is just by attending this event, you're already at that point where you should feel free to contact people like potential mentors or people at universities, for example, and mention that you attended this event. Like if you just cold email, like everybody cold emails in the world, and it's no disrespect, but faculty or PhD students don't have the bandwidth to respond to those. But if they see that, oh, I attended your talk or I attended this event that aligns with your research, then it's kind of like an instant, you're going to get a response. And, it may not always transition into a funded opportunity, but there will be that intent to hopefully match you with something going on at that place. So by attending this event, you're already there at that level where you can say, I attended this and I found XYZ interesting, right? So don't be shy, I guess.
Great. Thank you guys so much. I've literally just glanced over at Twitter and it is blowing up with you guys. So stay tuned and yeah, go and have a look, respond, interact. And straight after this session at 5 p.m. Eastern time, we'll have our pre-recorded video with Arnelle again, so you get a double dose, and with some other folks talking about a Q&A with about EEG. And also later on, we have the Twitter spaces, so make sure you jump in there. But that is everything from us today. So thank you so much and good night.
Thanks so much,
Thanks
future
so much.
Dr. Kelly.
Okay.